Yusuke, thank you very much for waiting.
No problem.
How
How
are
are you?
you?
I'm fine, thank you.
Long time no see.
Yes,
Are you at home today or are you in your office?
yes, I'm in my home.
Oh, congratulations.
Yeah.
Yeah. It's hot weather today.
It's rainy and hot.
It's raining in Tokyo.
Yes.
Really? That's terrible.
How about Osaka?
It's just hot and cloudy. It's not raining, but
Mm.
it's hot and cloudy. One moment. Ooh. Here, I'll use. The only thing you can use. There, that's better. Okay. Long time no English.
Yeah.
Welcome back to English. Yeah. Are you ready?
Yes.
Do you have any questions before we start?
Uh, no, I understand.
Okay, great. Let's begin. One moment. Draft storyline for presentation. Yes?
Yes.
Okay,
It's
here we
for
go.
next conference.
Here we go. Mm. Mm. You can see my screen?
Yes, I can see.
Okay. Do you see this? Hang on. Do you see this point here?
No, I
You
can't
cannot see
find the
the
point.
you cannot see the bottom of my screen. You see my arrow?
Yes, I can see.
Okay. Your red arrow should begin at that point there.
Yes.
I have to get this right. Okay?
Yes.
Where it contacts the surface.
Yes.
Okay.
Okay, I will
Yeah,
modify
thank
it.
you. Yeah. Uh I don't know what's happening here, but we'll discuss this.
It's elastic
Elastic
deformation.
deformation. Yeah, okay. But as far as this point here, now there is also the possibility of showing two vectors,
Mhm.
right? If you want to. This is the normal vector. In this case, it's negative. And then this is I think this is called the tangential vector. Sometimes it's called
Mhm.
the frictional vector, which
Yeah.
is based on the frictional force. Okay,
Yes.
so it's up to you whether you want to show it in one vector or two,
Yes.
because let's say C equals A plus B, something like that,
Mhm.
right?
Yes.
I'm going to put a circle around those so you don't get that confused. All right. Where C equals A plus B. All right. Thank you. The bending moment, that's another discussion. Let me read here. The draft storyline for presentation. The findings of this study are scheduled to be presented at the International Society for Prosthetics and Orthotics World Congress to be held in Thailand in March of 2027. Okay. The entry deadline is September 7th. Let's use comma 2026 of this year, right?
Yes.
Okay. To meet this deadline, we are proceeding with data organization and preparation of presentation materials. Okay, good. Do you have a question?
No, I have no question.
Okay. The study analyzed gait in individuals with unilateral trans-tibial amputation. Trans-tibial amputees lack an ankle joint, which serves as the primary source of propulsive force during gait. The primary source of propulsive force. I have a question.
Yes.
What about the Achilles tendon? What about the gluteus maximus? What about, right? So maybe we should change this to a major,
Mhm.
right? Do you understand?
Yes.
We have a chain of elements.
Yes.
And if we eliminate one element of the chain, then we lose a major element.
Yes.
But we can't say that any one element is the primary. Does that make sense to you?
Y-
I just
Yes.
I'm kind of curious why the primary was chosen.
Uh, uh, it means measure.
Yeah, okay.
Yes.
What was this a translated from Japanese by the AI?
Yes.
Yeah,
The
okay. So
part of
maybe
this.
maybe this was the AI translation's
Yes.
mistake here. Okay. And I don't know what the Japanese term was, omona or something like that. I'm not sure.
Mhm.
Yeah, okay. 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 Those are the only problems I have. Do you have a question?
No, I have no question.
Okay. Is there only one page?
No.
Okay,
Uh,
that's page
total.
one. Okay, coming back to you. Good, good, good. Good, good, good. Have you
Thank you very
received that?
much.
Thank
Yes,
you.
I received it.
Great, great. Hmm. Based on these findings, we hypothesize that on the prosthetic side, the ability to advance load anteriorly. Ooh, okay. I don't see any. I don't see any problems here.
Mm.
I do have a question. These diagrams, are these your diagrams? Did you create these diagrams?
No, it's from reference.
It's from the textbook.
Yes,
Yeah. Um, this arrow, is this your arrow or is this the textbook arrow? Did
it's
you
the it's arrows means
who added this arrow? Did you add these arrows or did was this part of the original textbook arrow?
it's from original textbook.
Yeah, and I would really like to see accurate de- um a more accurate depiction. I think the center is somewhere here. If I'm am I correct? So the
Mm.
arrow should look a little more like this.
Yes.
This arrow, I believe the center of the joint is somewhere here.
Mhm. Yes.
And then that would mean that this arrow should be perpendicular
Mhm.
to that center a little bit more carefully drawn here, something like that. And this one is almost right, but the center is somewhere in the this is so this is the heel.
Yes.
Okay. What is this area of the foot called?
That uh
It's called the ball.
yes.
Okay. And the ball of the foot would be the center and it's almost right on. This arrow is not so bad, but you I don't know if you want to extend it a
Mhm.
little bit, but if you could maybe modify those arrows a little bit, you'd have a better diagram. Otherwise, everything else, this is okay, and this one is okay. But I just I worry about these. They could be depicted a little more accurately. I don't think you need these extra lines, but if you paid more attention to the center of rotation in the three phases of the rocker function. Okay?
Okay.
The English is good.
Thank you very
I just
much.
don't like that arrow is not very accurate.
Mhm.
They weren't careful. Everything else is very nice. The bones, the bone depiction and everything is very nice. The gray moving to white, I like that. I just don't like that arrow is not careful. Okay, no questions.
Yes.
That means no. Yes means no.
Yeah.
Okay. It's a hot day today. Mm.
Thank you. I received the email.
Okay.
Yes.
Yeah. All right. Whoa. How many pages? Okay. Good. Okay. All text here. No. We have no diagrams on this page. Our preliminary investigation revealed that able-bodied individuals could shift their load from the heel to the toe over the course of a single gait cycle. Yes, okay. In contrast, individuals with trans-tibial amputation shifted their load only to approximately 60% of the heel to toe distance. Distance. Um, I'm thinking rotation or possibly angle. Do you understand? Instead of distance.
Excuse me. I can
Oh,
understand.
yes? No?
No.
Okay. So here is an example of distance, like X, right?
Mhm.
But here is an example of rotation or angle, right?
Uh, uh, in this case, it
Yeah.
is distance because
Oh,
he
because you are using translation of the CG as the reference.
yes.
Okay, so you are using distance. Okay, great. That was my question. Now, here's my question. Do you understand what mapping is? If we map from X to theta,
Mm.
what kind of relationship is there? If X shows a 60% relationship, what
Yes.
is the theta relationship? Is it the same 60%? I'm not sure.
Uh,
Mm,
mm,
okay, that's a question. I don't, maybe you don't have the answer,
yes.
but that's what we call mapping. Do you understand what mapping is?
Uh, relationship.
Mapping is if we move from what we call Cartesian to polar.
Mhm.
Sorry, polar. Polar would be r and theta,
Mhm.
whereas Cartesian is x and y.
Yes.
Okay.
Mm.
When we go from x and y to r and theta, this is what we call mapping,
Mm.
and there is consistent mapping, and then there is transformal mapping, which requires some type of functional relationship.
Mhm.
So I'm not sure if 60% in x is the same as 60% in theta.
Mm.
There may be some cosine uh, scaling,
Yeah.
right? Do you understand cosine scaling?
Yes.
Yeah, like for example, that maybe I'm 175 centimeters tall, but my shadow is only 100 centimeters at 3 p.m. And then at 7 p.m. or at 5 p.m. my shadow is 200 centimeters long, right? And that's
Yes.
that's called cosine scaling. So I
Mhm.
don't know what degree of cosine scaling exists. So cosine scaling, yeah, okay. So that's just a question here. Okay, so it is distance.
Yes.
Yeah, okay, great. This finding supports the notion that trans-tibial amputees exhibit insufficient loading of the forefoot and consequently insufficient forefoot deflection. Deflection, angular deflection. Okay, yeah. And deflection being the angle, right?
Yes.
Yeah, great. Oh yeah, so distance and deflection. Yeah, that's oh there we go. Yeah, it wasn't rotation, it's deflection. Thank you. Accordingly, the present study aimed to clarify a method by which transtibial amputees can sufficiently shift their load to the forefoot. Hmm. In the study, we used the forward velocity of the center of pressure as a quantitative variable to evaluate load transfer. Hmm. This is center of pressure on the amputate on the prosthetic side. Yes.
Yes.
Are you relating it to the center of pressure on the sound side also?
Yes. It's also
Okay,
relationship.
great, excellent. Okay. So in this study, we use forward velocity of the center of pressure, COP. I don't know if you want to say of both sides.
Mhm.
Oh, God. Sorry. And that's your choice. So I'll put those in parentheses. As a quantitative variable to evaluate load transfer. In this study, we used the forward velocity of the center of pressure as a quantitative variable. Okay, just had to check there. The COP represents the point of application of the ground reaction force on the plantar surface and indicates the location of load. We evaluated the speed of load transfer by measuring the velocity at which the COP moved forward from the heel to the forefoot during the first half of the stance phase. Okay. as a variable to evaluate as a variable to evaluate whether oh used there's the used I'm waiting for that yeah as a variable to evaluate whether load transfer to the forefoot was sufficient we used the timing of heel off. Okay. Previous studies have shown that heel off occurs when sufficient load has been transferred to the forefoot. Based on these considerations, we formulated the following research question. Does, oh, think you want a capital D there. Does a faster forward COP velocity during the first half of the stance phase correspond to earlier heel off timing? Good question. Any questions here, Yusuke?
Uh, I have a question
Yes.
about in this study, I use the word forward, but
Mm.
AI translation recommend me use anterior.
Oh gosh.
Which
Forward.
is the correct?
For, oh yeah. Well, okay. So for anatomy, right?
Yes.
Like um when you're talking about anatomy,
Mm,
I would say that anterior and posterior are the terms.
mm,
But when you're talking about mechanical motion,
yes.
I think forward is applicable.
Mm,
And you know, the person to ask is Sumiko,
mm,
not me,
yes.
because that's just my guess.
Okay, thank you.
And she would have the final advice on that. I would not
Okay,
see her until next Thursday, so I couldn't answer. But if you can contact her about that's an excellent question. That's a very good question.
thank you.
Yeah, my short answer is that anterior posterior uh refers to anatomy, and forward or rearward refers to motion, biomechanical motion. Motions of body parts relative to the body, it's not they're not free bodies. They're part of a linked system. But the human body itself is a free body in motion, right? So like motion of the center of gravity would be forward or backward, but the motion of the knee relative to the pelvis, is that forward or is that anterior, right? So Sumiko should be able to answer that for you.
Yes. Okay.
Okay, good. Other questions?
No.
All right. Where are you? AI is weak. I just have one question. Was this page originally written in Japanese?
Yes,
It was. Okay, thank you.
because I usually confuse right when writing in English.
Well, it notice it did a good job with this text here, right? Um yeah, it's a final filter. I guess you received this one. Yeah, okay. Mm. Ooh. A sorry, a preliminary analysis of 11 participants to date has shown this trend. Shown this trend. Okay. This finding suggests that increasing the forward velocity of the COP may contribute to sufficient load transfer to the forefoot. Uh, I don't know if I would say improved. What is sufficient, right?
Mm,
I mean, if sufficient just means enough, like 60% is efficient for walking. Oh,
mm,
I'm sorry, sufficient,
yes.
but it's not as good as 100. What is sufficient, right? I
Mm,
mean, improved is better than 60, right?
yes.
If it's somewhere better than, if it's 65, that's improved. If
Mm,
it's 70, that's improved.
yes.
Will you ever reach 100? Well, improvement is the goal,
Mm,
right? Okay. Okay. As a next step, we are planning an experiment using an off the shelf carbon insole, a device designed to increase the forward velocity of the COP. This insole has previously been used in patients with post stroke hemiplegia. However, given its mechanism of action, it may produce a similar effect in prosthetic users. Ooh. To date, we have collected data from approximately 20 individuals with trans-tibial amputation. Given the September conference entry deadline, we will be able to. Not so sure about that. Nobody knows. To analyze data from a maximum of approximately 10 participants. Therefore, this presentation will. This is micro help here. It's not so different. Yusuke, any questions here?
No, I don't have question.
Okay. Why does the AI not understand that I'm trying to send you? I have to go into line and do this extra step because the AI,
Mm,
I get the sense that Apple doesn't have permission. They don't share enough of the API or something. No, well, I don't know why Apple's AI is so poor. Today I stood up to use the toilet, and just as when I stood up, after I stood up, my watch said, "You should stand up." After I stood up, the watch said, "Stand up." Not very happy with the AI. Okay. Okay. Where are we? Done. Would you like to read?
yes.
All right. Can you see my screen?
Yes, I can see.
All right. Please read.
Okay. Draft storyline for presentation. The findings of this study are scheduled to be presented at the international
Findings.
findings.
Yes.
The findings of this study are scheduled to be presented at the International Society for Prosthetics and Orthotics World Congress to be held in Thailand in March of 2027. The entry deadline is September 7, 2026. To,
Okay.
yeah, to meet this deadline, we are proceeding with data organization and preparation of presentation materials.
Okay, time out for a second. Orthotics. Orthotics. So we have OA, like post office, orthotics.
Orthotics.
Yes. And preparation, not preparation, but preparation.
Preparation.
Yeah. Okay.
Okay.
Presentation, preparation. Okay.
Presentation.
Yes. Okay. All right.
This study analyzed gait in individuals with unilateral trans-tibial amputation.
Mm.
Trans-tibial amputees lack an ankle joint, which serve as a major source of propulsive force during gait.
Amputees.
Amputees.
Yeah.
Consequently, these individuals exhibit a marked deficit in push-up force.
Exhibit a marked deficit. Exhibit a marked deficit.
Exhibits a marked deficit.
Yeah, the H is almost silent. It's exit. It's not exhit like exhale. It's exhibit. So the H is effectively silent. Exhibit a marked deficit.
Exhibit a marked deficit.
A marked
A,
deficit.
ma- a marked deficit.
Marked deficit.
Marked
So you
deficit.
can use the same old hey saw there. Marked deficit.
No, marked deficit.
Marked deficit.
Marked deficit.
That's better. Yeah. Okay.
Most current prosthetic feet are made pri-
Pry.
primarily,
Pry. Pry.
primarily, primarily,
Primarily.
primarily,
Prime.
primarily,
Mary. Primarily.
primarily,
Primarily. One, two, three,
primarily,
four. 1, 2, 3, 4. Primarily.
primarily.
Okay, better. Yes.
Most current prosthetic feet are made primarily of carbon or glass fiber.
Mm.
These prosthetic feet compensate for
Compensate.
com-
Compensate.
compensate
Mm.
for push-off force by utilizing the elastic deformation of their constituent materials.
Constituent materials.
Constituent materials.
So we have constituent materials. Constituent materials.
Constituent material.
Very good. Much better. Yes.
However, the resulting output remains
Substantially.
substantially
Mm.
lower than that generated by a healthy ankle joint.
Mm.
To increase push-up force on the prosthetic side, greater load must be applied to the forefoot of the prosthetic foot in order to produce larger elastic deflection of the materials.
Okay, of the material.
Of the
Of
materials.
material.
Uh, of the material.
Good. Okay.
Okay.
Do you have a question on this page?
No.
Okay. Um. O, A, E, English. Difficult.
Yes.
Yeah. Presentation, preliminary, uh, preparation, proceeding, orthotics, Congress, and
Mm.
foot,
Good.
foot,
Good.
uh.
Good.
So we have two forms of oo,
Mm.
like zoo, spoon, and foot, book. In this case, foot.
Good.
Prosthetic foot.
Prosthetic foot.
That's better. Okay. No questions here.
Yes.
That means no. Yes means no.
Yes,
No
no, I have,
questions. No
no, I
questions.
don't have question.
No. Okay, good. Go ahead.
Okay. The human lower limb processes,
Possesses.
ah, possesses, po-
Possesses.
possesses
Mm.
a mechanism called locker function, which
Mechanism.
mechanism
Mm.
called, called locker function,
Called. Ka ki ku ke ko. Called.
called,
Mm.
called locker function,
Rock. Called rocker.
locker,
Called rocker function.
called locker function,
Called rocker.
called locker,
Rock.
uh,
Called rocker.
called locker.
So this al is ah. This o is ah. So it's
Mm,
the same sound. Called rocker. Called rocker.
called locker.
Very good. Good. Which
Which smoothly advance the body's weight over the hood
advances.
advances
Mm.
the body's weight over the hood in the forward direction.
Okay. Do you know Usagi?
Yes,
Do you know the bite the lip? Foot.
hood,
Foot. Yeah. F is biting, and V, we bite the lower lip with the upper teeth, like just like a rabbit. Foot forward.
hood, forward,
F-
hood.
I don't know. Can you see me while I'm sharing my screen? Can you see my face? No,
Yes,
you can.
I yes I can.
Foot
Hood,
forward.
forward,
Function. I'm exaggerating, but foot,
hood,
foot, foot.
hood.
Better.
Mm,
Keep practicing.
yeah.
Okay.
like a rocking chair. This
Rock.
rock,
Yeah.
like a rocking chair.
Mm.
This me- mechanism allows
Mechanism.
mechanism
Mm.
allows movement
Allows.
allows
Mm.
movement to proceed continuously without interruption.
Good.
Raka function consists of three sequentially
Sequentially.
sequentially
Se- sequentially.
sequentially
Mm.
acting components:
Mm.
the heel rocker, the ankle rocker, and the forefoot rocker.
Mm.
The heel rocker arises from a rolling motion utilizing the curvature of the calcaneus
Mm. I think it's calcaneus.
calcaneus,
Mm.
while the ankle rocker arises from motion at ankle joint. However, prosthetic feet lack both of these mechanisms.
Prosthetic feet lack both of these mechanisms. Prosthetic. Prosthetic.
Prosthetic,
Mm. Prosthetic.
prosthetic,
Prosthetic.
prosthetic
Yes. Mechanisms.
mechanisms.
Good. Improving. Oh, we at the bottom here. Sorry.
Based on these findings, we
Based.
based
Mm.
based on these findings, we hypothesized that
Hypothesized.
hypothesized
Hypothesized.
hypothesized
Mm.
we hypothesized that on the prosthetic side, the ability to advance the
Advance.
advance the load anteriorly after heel contact is limited,
Mm.
and that this limitation contributed to insufficient loading of the forefoot.
Contributes to insufficient loading.
Contribute to insufficient.
Contributes to insufficient loading.
Contributes to insufficient loading.
Mm. Yusuke, any questions?
No, I don't have question.
Okay.
I need just practice.
This is good practice. I know you're taking mental notes, and I know you're going to be using probably the Google Translate sentence by sentence. And I guess we're on schedule for Monday. Yes.
Yes.
You might have some red words for me, right?
Yes.
Okay, great.
Our preliminary investigation revealed that able-bodied individuals could shift their load from the heel to the toe over the course of a single gait cycle. In, in contrast, individuals with trans-tibial amputation shifted their load only to approximately 60% of the heel to toe distance. This finding supports the notion that trans-tibial amputees exhibit insufficient loading of the forefoot and, consequently, insufficient forefoot deflection. Accordingly, the The present study aims to clarify a method by which trans-tibial amputees can sufficiently shift their load to the forefoot. In this study, we use the forward velocity of the center of pressure (COP) as a quantitative variable
Quantitative.
quantitative
Mm.
variable to evaluate load transfer.
Quantitative variable.
Quantitative variable.
Variable. Vacation. Mary. Quantitative variable.
Quantitative variable.
Good.
Quantitative variable to evaluate load transfer.
Mm.
The COP represents the point of application of the ground reaction force on the plantar surface and indicates the location of load. We evaluated the speed of load transfer by measuring the velocity at which the
Velocity.
velocity
Mm.
at which the COP moved forward from the heel to the forefoot during the first half of the stance phase. As a variable to
Mm.
evaluate whether load transfer to the forefoot was sufficient, we use the timing of heel off. Previous studies have shown that heel off occurs when sufficient load has been transferred to the forefoot. Based on these considerations, we formulated the following research question. Does a faster forward COP velocity during the first half of the stance phase correspond to earlier heel off timing?
Heel off occurs. Heel off occurs.
Heel off occurs.
Heel off occurs. Heel off occurs.
Heel off occurs.
Heel off occurs.
Heel off occurs.
Heel off.
Heel off.
Heel off.
Heel off.
It's kind of like pilaf. You know, pilaf.
Pilaf. Yes.
Heel off.
Heel off.
Yeah. Okay. Better. Questions?
No, I don't have question.
No questions. No question. Oh, wait. Last one. Hmm.
A
Go ahead.
preliminary.
Preliminary. Preliminary.
Preliminary.
Preliminary. 1, 2, 3, 4. Preliminary.
Preliminary.
Sorry. Preliminary. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Preliminary.
Preliminary.
Yes.
A preliminary analysis of 11 participants to date has shown this trend.
Mm.
This finding suggests that increasing the forward velocity of the COP may
Mm.
contribute to improved load transfer to the forefoot.
Mm.
As a next step, we are planning an experiment using an off-the-shelf carbon insole,
Mm.
a device designed to increase the forward velocity of the COP.
Mm.
This insole has previously
Previously.
previously
Mm.
been used in patients with post-stroke hemiplegia.
Mm.
However, given its mechanism of action,
Mechanism. Mechanism.
mechanism, yes. However, given its mechanism of action, it may produce a similar effect in prosthetic users.
Mm.
To date, we have collected data from approximately 20 individuals with trans-tibial amputation. Given the September conference entry deadline, we should be able to analyze data from a maximum of approximately 10 participants. Therefore, this presentation will report preliminary trends based on the small sample size.
Report.
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 Okay. Yusuke, that's pretty good. Do you have a
Thank you very
question?
much.
My
No, I have no
pleasure.
question.
Oh, good, good. That's good. Very
Very,
technical English.
yeah.
Very difficult. Now, just to remember, repeat after me. A,
A, A,
E,
E, E,
I,
I, E,
I.
E,
Yeah.
E,
O,
O, A,
U, U,
U, U, A,
uh, uh.
A, A.
Yes. Okay. Like in Japanese, onyomi, kunyomi, each vowel has two or maybe more lives,
Yeah.
sounds. And that's the challenge. Post office.
Post office.
Yeah. Yeah. Um, T-set. Yeah.
いいえ、
どういたしまして。T-set. Yeah. Pre, pre, re, re. It's case by case for
え、
each word. So as you're listening, make a note which one it was. For native speakers, it's natural to us.
え、
But for students, I think once you've been introduced to this concept, the katakana, it kind of destroys the whole concept.
うん、
And the Japanese, yomi kata is consistent. Other languages like Italian
うん、
or German are consistent, right? And an is an an is an It doesn't have multiple lives, right? But in English, e o a, right? So while you're listening, uh, keep in mind, okay, is this O and O or is this O and A? Is this A and an A? Is it an A or is it an A? See, has three lives, but they all have a chance to be an because if they're not stressed, they're a schwa.
うん、
The schwa is the
え、
upside down E thing, which is like bus. Okay. Or nothing. They may not contribute a sound at all. Right. So native speakers, when we're spelling a word, we're like, wait a minute, is that an I or an E? Because the letter makes no sound
うん、
and we forget how to spell.
うん、
It's not like katakana. It's not like a furigana where it's consistent. Yeah. It's English. It's a lot like French. French is like that. French has all these crazy spellings. I think it was the French influence. See, English, the Romans gave us Romaji.
うん、
We didn't ask for that. So the Roman alphabet is an ateji.
うん、
It doesn't fit. it's kind of an approximation. It's about.
Yes.
Or act, if we really wanted to uh, represent English, we would use the Viking runes. Did you
Mm.
know the Vikings had a writing
Yes.
system? But we don't. We use ABCs. Okay.
Mm.
Can't change history. But yeah, keep that in mind, the dual nature of every one of these vowels. Your R's are a little weak, and that takes time to develop a stronger R. We practice the a little bit. Just think usagi,
Yes.
eating a carrot, foot. Talked about o u and o spoon and book.
Mm.
Okay,
Okay.
that's a big plate. I will see you Monday,
Yes.
and you'll have some red words for me. And any grammar questions that you have. Otherwise, the grammar was not bad.
Mm.
I think AI is improving.
Mm.
It's challenging. Oh, don't forget to ask Sumiko that question about forward and anterior. I
Yes.
think she'll have a lot of good insight on that one because she reads a lot of papers. Okay, Yusuke, any other questions?
No, I have questions.
Okay, I'll see you Monday.
Yes. See you Monday. Thank you very much.
Stay cool.
Oh,
Stay cool.
it's room temperature.
No, that's the setting. That's
Mm.
the target.
Mm.
What was the temperature here? I think what was the maximum here? It was it's 33 now, but it was 37 was the maximum.
Mm.
So red. It's gonna cool off a little bit. It's gonna rain. Oh no.
Oh.
Okay. Thank you. I'll see you Monday.
Yes. See you Monday. Thank you very much.